In this video lesson, we're going to spend some time reviewing the ideas of volume and surface area. This is important for grade 10 students because, as we know, Chapter 1 of our Math 10 course is all about measurements, and especially about applying those measurements as part of problems to solve. And for those problems, this course assumes that students remember how to find the volume and the surface area of different simple figures. To begin with, we remind ourselves that volume is the space inside of a three-dimensional object measured in cubed units of length. So we might talk about centimeters cubed, or we might talk about feet cubed. These would also be referred to as cubic centimeters and cubic feet. When we discuss volume, it's pretty typical to begin by discussing the idea of a prism. A prism has two congruent faces. So in this first example, we have two congruent triangles. In the second example, two congruent hexagons. These congruent faces are known as the base. They're at either end of the prism, and they're joined by some rectangular faces. The length of these rectangular faces is the same as the distance between the congruent faces, and this distance is known as the height of the prism. What may be very different for many students this year compared to previous years finding volume is that we don't give you different volume formulas for different prisms. Your formula sheet will simply tell you that the volume of the prism is calculated as the area of the base multiplied by the height. This is why it's so important to be able to identify the base. In this case, my two congruent figures, the two shapes that are the same as each other, are the two triangles. So this is a triangular prism, and its volume is going to involve finding the area of each of those triangles. In this case, 1/2 multiplied by 15 multiplied by 8. And then we're going to multiply by the height of the prism. Remember, the height of the prism is the distance between those two base faces. So in this case, our height will be 12. In terms of showing work, you should always show us what numbers were substituted into your formula before you show us a final answer. That way, if any small calculation errors have been made, we know that you still understood which formula to use. As another reminder, don't forget to include units with your final answer. In this case, the volume of this triangular prism is 720 cubic centimeters. Aside from prisms, we expect that our grade 10 students have also worked with finding the volume of a cylinder. A cylinder has two opposite circular faces that are joined by one smooth curving face, and the distance between the two circular faces gives us the height of the cylinder. The volume of a cylinder follows the same general pattern as the volume of any prism. However, we often see this given as a volume formula of pi r squared multiplied by h. Notice that the area of a base is a circle, so the pi r squared is the area of that base, and multiplying by the height remains the same. In this particular example, the volume of this cylinder would be equal to pi multiplied by 4 squared multiplied by 10. If I was going to show a little bit more work, I would remember that squaring happens before multiplication, since it's a form of exponent, and I would make sure to show that this is pi multiplied by 16 multiplied by 10, so that the volume of this particular cylinder is equal to approximately 502.6 cubic inches. Our other important idea of this video lesson is the idea of surface area. Surface area is the total area of all the faces of a three-dimensional object, and since it's an area, it's measured in squared units. It's important to know for grade 10 students that there's no formula given for the surface area for objects that are composed of polygons, rectangles, triangles, hexagons, and so on. So we expect our students to apply critical thinking skills. In the case of this triangular prism, we'd want students to recognize that the shape is made up of two triangles, all the same size, as well as three different rectangles. And we can tell that these rectangles are different because one rectangle involves an edge of 5 centimeters, another rectangle involves an edge of 4 centimeters, and the last rectangle involves an edge of 3 centimeters. So that if we're talking about the surface area of this figure, we're going to have two groups of 1/2 multiplied by 4 multiplied by 3. That comes from our base and our height of the triangle. And then we're going to add a rectangle which is measuring 3 centimeters by, not 10, but for this question, 11 centimeters, and a rectangle that measures 4 by 11, and a rectangle that measures 5 by 11. When we perform all of this multiplication and addition, ultimately we find out that this triangular prism has a surface area of 144 centimeters squared. And remember, since this is an area, our centimeters are squared and not cubed. For questions related to surface area, some students may find it helpful to draw a net diagram, which is a two-dimensional representation of the surface of a three-dimensional object. It's almost as if we cut open some of the edges of the object to unfold it and see what it would look like if it was completely flat. Then students can start to fill in measurements on their net diagram, which might be a nice visual way to see what the rest of this object looks like, and then start finding the area of each of the faces represented in the net diagram. On the other hand, when it comes to the surface area of a cylinder, you will be given the formula. For a cylinder that's completely closed with all of the top and bottom and sides, the surface area is 2 pi r squared, representing the two circles that are part of the cylinder, and 2 pi r h. This last piece gives us the surface area of the curving edge of your figure. So if we were going to find the surface area for this particular cylinder, we're going to look at two groups of pi multiplied by 4 squared, and two groups of pi multiplied by 4 multiplied by 10. Altogether then, this cylinder has a surface area of approximately 351.9 squared inches. And that's our quick review, so that you can correctly find the volume or the surface area of any three-dimensional object. For some other kinds of objects, including cones and spheres, we'll talk about those volumes and surface areas more in class.